Hello, once again welcome to Mathline channel. In this channel you will be getting a basic maths lesson every week. Those who have not watched the previous lessons, please watch from the beginning and continue watching. Also share as much as possible to the students of all standard. So let us start today's lesson with a new topic, that is factor theorem. This is also related to the division of polynomial by a binomial. It is derived from the remainder theorem only. So what it is? When P of x is any polynomial and if P of A is 0, then x minus A is a factor of P of x. We know that when P of x is divided by x minus a, then P of a is the remainder. When the remainder is 0, we know that divisor is a factor. That's all. So that only the factor theorem. Clear? P of a will be the remainder when P of x is divided by x minus a. So if P of A is 0, then x minus A is a factor. In other words, if remainder is 0, divisor is a factor of the dividend. That's all. So this is obtained from remainder theorem only. This is used to test whether the given binomial is a factor of the given polynomial. So let us see some examples. There is a polynomial in x, that is P of x equal to x square minus 7x plus 12. Find whether x minus 1 is a factor or not using factor theorem. To test whether x minus 1 is a factor or not, what you have to find? P of 1. If P of 1 is 0, then x minus 1 is a factor. If P of 1 is not equal to 0, then x minus 1 is not a factor. So to test x minus 1 is a factor, what you have to find? P of 1. So P of 1 how to find? Substitute x is equal to 1. 1 square minus 7 into 1 plus 12. 1 square is 1, 1 minus 7 minus 6 plus 12, 6. So remainder is not equal to 0. Here the question is not to find the remainder, to test whether it is a factor. So in order to test that, we have to find the remainder using remainder theorem. Clear? So P of 1 is not equal to 0. Only you have to test whether it is equal to 0 or not. So we got it is not equal to 0. Therefore, x minus 1 is not a factor of P of x. Now another one, for the same polynomial, whether x minus 2 is a factor or not. So what you have to find? P of 2. So substitute x is equal to 2. So 2 square minus 7 into 2 plus 12. 2 square is 4. 7 2s are 14. So 4 minus 14. 4 minus 14 minus 10. Minus 10 plus 12, 2. Here also the remainder is not equal to 0. So what you can write? X minus 2 is not a factor by factor theorem. Another example, for the same polynomial, to test whether x minus 3 is a factor or not. So for that, what you have to find? P of 3. So substitute x is equal to 3. 3 square minus 7 into 3 plus 12. 3 square 9. 7 into 3 minus 21 plus 12. First we will add the positive. 9 plus 12, 21. 21 minus 21, 0. So what is that? X minus 3 is a factor of P of x by factor theorem. Next, to find x minus 4 is a factor or not. To find x minus 4 is a factor or not, we have to find P of 4. So, P of 4 equal to, substitute x is equal to 4. 4 square minus 7 into 4 plus 12. 4 square 16, 7 fours are 28 minus 28 plus 12. We will add the positive. 16 plus 12, 26. 26 minus 26, again 0. Therefore, x minus 4 is a factor of the given polynomial. So, two factors we got of this polynomial. What are they? X minus 3 and x minus 4. Clear? By splitting the middle term, you know how to find the factors. Clear? So those numbers 3 and 4 equal to 12, 3 plus 4 equal to 7, and both are negative. From that it is understood that x minus 3 and x minus 4 are the factors of x square minus 7x plus 12, right? So by factor theorem we can check whether the given binomial is a factor or not. And what is the condition? The binomial in the form of x plus a or x minus a. You have to find the value of the polynomial. It is nothing but remainder. If the remainder is 0, divisor is a factor. Clear? So that is the end of today's lesson. Thank you for watching this lesson. Please share and forward as much as possible. See you next week with a new topic. Have a nice day. Bye bye. See you.